Didn't see you there. Want to learn about predator-prey relationships in biology? Keep watching this video. Once upon a time, there was one predator who ate, because that's what you do to survive. And this predator had to eat 3 prey in order to live. For the first few generations, the predator sadly died because there were only 3 original prey to eat. And he was dumb. He couldn't find them, and he couldn't eat them. So the prey just kept doubling, and a new predator came along each generation to continue eating the prey. So eventually, one young predator found 3 prey to eat. Wow, he lived, and then he doubled the next generation. One predator went to 2 predators, and this process continued on for 20 generations. During the 20 generations, the predators continued to double and double, eventually almost to the rate of the prey, causing the prey population to decrease. Since the population of prey decreased, the predators also began to die off because they were not able to capture all 3 prey. Finally, the prey population began to rise again, and all was well. Here's the graph of our results from our experiment, and it's the predator-prey relationship, and you can see that the graph fluctuates. Overall, this experiment relates to the theory of Thomas Malthus. He said that while populations tend to produce geometrically, not all of them will survive because of natural selection from predators, which affects the prey, and lack of food sources, which affects the predators.
Want to further indulge your interest in the relationship between predators and prey? Keep watching for us to conduct our second experiment.
Once upon a time, there again was one predator who, guess what, ate food. Because life, except this predator was a lanky child. He only had to eat 2 prey to survive. Once again, for the first few generations, the young lanky predator was dumb. He couldn't catch 2 prey to eat. Thus, he died for the first few generations. But some other lanky predators came along in the next generations, so like the other story, the surviving prey doubled. So eventually, one talented young lanky predator found 2 prey and he ate them, and guess what? He survived. Then the predator doubled, and the process continued on for 20 generations. During the 20 generations, the predators continued to double and double and double, eventually almost to the rate of the prey, causing the prey population to decrease. Since the population of the prey decreased, the predators began dying off again because they could not capture all 2 of the prey. Finally, the prey population began to rise again, and all was well. Once again, we graphed our results. As you can see, the graph fluctuates.
Okay, time for some conclusions. But how are the results from our experiment different from the results from the control experiment? Clearly, a predator needed to consume less prey in order to survive, as we changed the number from 3 to 2. So, from our experiment, we are shown a more magnified predator-prey relationship, as predators rely less on prey to survive. And since there are less prey in the area, it's also harder to easily capture the prey that are needed to survive. Thus, we have more predators and prey survive at the 20th generation than we did in our control experiment. So, our experiment proves that in our controlled environment, where there are no other predators to compete with, lanky predators who eat less prey are more likely to survive than non-lanky predators who eat more prey. So eventually, one young predator I said eventually twice. Overall, this experiment relates to the theory of Thomas Malthus. He said that while populations tend to produce geometrically, not all will survive. I can't say